Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
This is the Digital Enterprise Society podcast. This is the podcast that addresses strategies to enable enterprise transformers and decision makers to understand how digital tools and techniques deliver superior results in the global competitive marketplace. My name is Thom Singer, and I have the honor to co-host this show every week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors, and Craig continues to serve the community of PLM as a senior advisor and mentor. Hey, Craig. How you doing today?
I'm doing great, and I'm glad you got out of town before we got snow and cold. So it to all of our listeners, Thom and I finally got back together face to face. It was fabulous last week here in Detroit, and we're going to have to do that face-to-face thing more often. We had a lot of fun.
The original plan when we started the podcast is that we'd go around to a bunch of these different industry events and we'd interview people live and do some live on stage type things that would become episodes. Yeah. And then the pandemic hit and we weren't able to do it, but we did at the Digital Enterprise Society at their Digital Intersect Conference, and we recorded an episode. We might split it into two, which was one of the digital battles with you and Mark. And so I'm looking forward to that coming out as well.
Yeah, so it was great to see you, and today we're going to go back a little bit about what enables digital twins. We debated a lot in that battle. We don't really battle, but we sort of battled. It depended on the question, right?
It's really the digital love fest when you and Mark get together.
I wouldn't go that far, but in any case, in order to make it all work, you need to make it interoperable, and that's our guest today is going to chat a little bit with us about what he does that enables that. So
awesome. Well,
here we go.
Every single week, Craig and I try to bring to the show interesting interviews and other ideas that are going to enhance the careers of all our listeners. And today we are joined by Robert Baillargeon. Hey, Robert, welcome to the show.
Oh, thank you so much. I'm happy to be here. It should be great fun.
Robert is the Chief Product Officer at SodiusWillert. And what he does is he is the conduit that helps improve teams' processes. What he does is he makes teams better. And when he leaves, he doesn't want them just to do what he said because he said so, but he wants them to actually take action because there's value in what he said, and he really wants to help people make their jobs better. He does a little bit of stuff in some different areas, both sales and marketing and support, but in reality, his whole goal is to make tool integration easier. So, Robert, we're really glad to have you here. Can you give us a little bit of your background?
Yeah, happy to give my background, and I need to bring you everywhere I go to be able to do such an introduction. That's fabulous. So my background is I was a kid growing up in the Detroit area, so the only thing that you thought happened in the world was automotive. So I hit that life goal early on, working as an engineer at GM, and being able to help build cars, build products. Along the way, I got to learn how to be able to help build process and be able to make teams better. And got to be able to bump around to a couple other types of organizations, one being Panasonic Automotive, where I got to work on the transition between moving from just simple radios and audio systems to these infotainment systems that are just in every vehicle that's in the market right now. Great transition between typical embedded and our dynamic environment of infotainment and consumer electronics. And then the past about 10 years, I've been working in basically the consulting space and now more recently in the product space on how to be able to take those processes, make those teams better, and be able to deploy tools that work well together to be able to have teams be successful. So it's been great fun to be there and great fun to be able to work with a lot of large automotive companies, large aerospace and defense companies, and be able to work with people like Craig to be able to see the industry grow and succeed.
So, Robert, it's great to have you here. And Thom and I finally got together last week. Robert and I actually saw each other in May, and it's at one of these Process Insights. It's a particular company that we've both worked with as consultants, and I do some writing for them. But at that conference, we caught up with each other, and the topic on my mind that day was interoperability, particularly between systems. There's lots of solution vendors that have lots of tools, and some of them even have a broad enough tool set that they say, well, just use our tool set and you don't need anything else. And in reality, at least at our big companies, we have multiple tool sets, typically maybe focused on a discipline like electrical engineering or embedded software engineering or mechanical engineering. And then even within those domains, you'll get digital electrical engineering and you'll get wiring harness, power grid, electrical engineering, and they're different things, right? And so the question then becomes this whole idea of a digital twin, or we've heard some people say a source of truth, right? Well, how do we get to that if in fact our design data is in different silos? And so, Robert, you and I were together, and I think the single solution vendor notion is flawed. but I'd like to hear.
Well, that's good. Otherwise, this conversation might be very short.
Well, you wouldn't be working where you're working, and in fact, you've been doing it for a decade, so there's some insight there, right? So what's the market demand for interoperable systems, and for that matter, interoperable processes?
Yeah.
What is the market? You guys are in a good seat for this. SodiusWillert's been around for a long time. You've been there for over a decade. Fill me in. What's the market?
Yeah. I mean, I think that's a great place to be able to start. I mean, I think we might be able to take the next 2 hours talking about that. But let's see if I can be a little simpler on that.
That just means there is a demand, right?
there absolutely is a demand, and there's always been a demand. I mean, our history in Sodius has always been on integration for system engineers, and system engineers were the engineers that didn't have one tool of discipline. They had all tools of discipline. And so we were finding ways to be able to bring data together so they can make decisions. And I think we see that in the industry just much more broad now. And the idea being that we've kind of gone through these different generations of having client side tools that we tried to import data to have some server side tools to, as you talked about, we'd have some vendors who say, just import all the data into our tool. In the reality, though, with these large enterprise systems that we have, there isn't just one tool. There isn't just one repository. There's a much broader notion of we need to have interoperability, and what does that mean? And how do we satisfy the need of engineers while also balancing the needs of IT and the engineering integrity? So working with, for example, working with aerospace and defense companies, it's not just whether or not you can integrate the data. It's whether or not you can keep the metadata around there, as well as preserve security and access controls. So people get the information they need when they need it, but only the people that are allowed to see it can see it. And so these infrastructures, building these structures together has become much more complex. I mean, the early answer that we've been working with in the last 20 years of use an API and import data in doesn't necessarily scale well. You don't usually have the ability to be able to say, oh, by the way, on this data, I only want to preserve it for these user IDs. And by the way, I'll tell you later on when they're no longer active. You need to have a much more pervasive environment in which not only is it the digital twin, but the digital thread that engineers themselves can get on and be able to navigate through and see the information they should see and be able to do the analysis they want. So we've been active in a standard called OSLC, which was brought about to help address those questions, to be able to build on web technologies, RESTful interfaces, and be able to add on some semantics in terms of how do we link these different repositories and how do we have data come together. We have,
So there's a demand, and you said something about RESTful, which a couple of us know what that means, but a lot of the people won't know what it means. The internet, right? We're able to do things on the internet because of this loose coupling, but there's a cooperation on the way websites communicate with each other, right? This application programming interface, or API, it tends to be point to point, and that's why it doesn't scale, is because as you add points, it can be an n squared problem, which means for every point you add, you got, that many more connections you have to remake. So I think maybe describe for our audience RESTful, maybe where it came from is also, it's a standard, but also there's a shortcoming, right? I think we've talked a bit about this notion of a configuration. So teach us a little bit about RESTful and then the importance of passing a known configuration.
Sure. Those are great questions. So RESTful is we can think of that as the way in which we can communicate on the web, ways in which we can transact information without state, and just the natural way in which we might want to interact between a web server and our application, and more likely server to servers, to be able to make sure that as I interact with the server, I'm always going to get the information I need, and it's a consistent way in which I can operate. And as Craig says, there's standards out there to be able to understand all the details about it, and that's what our development team spends a lot of time on, to be able to make sure that they operate in that realm. But we see a lot of applications building interfaces that are RESTful, and that allows people to be able to interact with them. What it doesn't do, and I think, Craig, you alluded to this, is this question of context or configuration. And context and configuration is an interesting notion. So typically when we think about integrations, we're talking about how does a requirement relate to a test case, which relates to some change request. And that's a common notion, common thread that we can interact on. The question is, which version of that requirement, which version of that test case relates to that change? And that's the notion of a configuration. So we work in a natural in the engineering area. We might say that we're working for a particular product release or a particular stream of development. And that's a very natural way for us to interact. And tools like in our source control, we'll have streams that we contribute to. In our PLM systems, we'll have EBOMs, bills of material that we assemble together to be able to bring the right versions of parts together. What the challenge is, or at least the challenge that we're seeing right now, is how do those different, we'll call them micro configurations, local configurations, build up into an enterprise configuration? How does a mechanical engineer working in a PLM system that has a particular part relate to a particular set of requirements that it might be developed in a stream within another tool? And that's where the challenge is going to be in the industry now, and where standards need to take place to be able to say, how do we compose and build these configurations? So as I navigate these relationships, as I navigate these links, I can be able to see the right artifact, the right version of that artifact, and a known artifact version. And that's kind of the technical side of it in terms of what we're trying to accomplish. The other...
So in a mechanical sense, that's a mock-up. That's a representative of the product in order to make some decisions, right? So a configuration is a prototype, and then everything we read about, it's a digital twin. Well, the one reason I don't like the word digital twin is people say, there is one, and once we have it, we're done. Well, nothing could be further from the truth. You have a bunch of them, right? Every configuration should or is a digital twin of some sort, right? It
is. It has a purpose. It has a value. It has an owner. Right. It has a concept. And that is kind of the challenge that we have, is how do we compose these, and who composes these, and who's the owner of setting what that configuration is and what it should include.
So where does the configuration live then? Because it could be cross silo. If it's not in one silo, how do you organize that? That is I was going to say $1 million question, but inflation, I think that's like the $100 million question. Is where does that configuration take place, and who owns that configuration? Who manages that configuration? Now, typically, historically, engineers are the ones that have managed these type of cross repository, and so the silly answer is that configuration resides in somebody's Excel file somewhere. That's probably the silly answer, because that's where everything resides, is in an Excel file somewhere. And it doesn't have a version, and it's not under control.
A version. It's sitting in SharePoint or somebody's laptop somewhere. But we've gotten smarter. These have to reside elsewhere. And that's where you get into what you talked about before of a single tool solution. So we had some of the large vendors who were saying, okay, the configuration is owned in our tool. And so what you need to do is export it from these other tools and put it in, and then we have one configuration. We have one particular vendor who's created a concept called a global configuration manager that allows other tools to contribute their own micro configurations into that global configuration, and then it can query to be able to find out which other configurations participate. So this way you could integrate what your PLM configuration is next to your requirements management configuration in conjunction with your test or quality configuration as well as other systems. And that's evolving. The challenge is always getting to, well, who owns that configuration? Because logically, every vendor has realized this is actually the most important thing to be able to own is the configuration for the entire sets of digital threads, because you can do so many fantastic things with doing that beyond just bringing data together, but also being able to talk about your reuse patterns. How do you recreate these systems? How do you be able to make derivatives from the system? This is owning the enterprise data, the enterprise IP, how to be able to manage this configuration.
Yeah, but even those silo solutions that are really powerful, like in the company we both worked for at one point, what really drove mechanical PLM? Well, the truth is mass production, right?
Yeah.
And so that bomb, that E-bomb that became the M-bomb, was driven by mass production efficiency. That is not the right configuration to look at when you want to look at sharing requirements across product lines that might be produced in very different plants at very different points in the world. And so the whole feature product line, which, you and I have talked about in the past and other people we work with talk about, that's a completely different way of looking at it. Some of the information is the same, by the way, but it's a different wing. It's not the point of mass production. It's the point of architecting a product line. And it shouldn't be surprising as you dive into that, why those are different. So we should have different configurations off similar or pieces of the same data, I think, right?
Oh, yeah. I absolutely agree, yes.
And so then where does that product line configuration live? Is it in the BOM system or somewhere else? I mean, it's really, this is a volatile topic, I know, but you guys are solving this. I mean, this is why you're here, right?
I think it's the natural evolution that we need to get to. I mean, product line engineering from the software side has been around for the last 20 years in different variations. And over the last 10 years, it's gotten much better tool support, but that tool support is kind of this manual integration. What you're talking about and what we envision is a much broader set of, yes, we're dealing with these digital threads and we're dealing with these configurations, but configurations are variants of other configurations, and being able to both compare those configurations, see the differences, see the deviations, see the configurable points of that or the variance points of that is going to be wickedly important for us going forward. So we're going to do some baby steps here. Number one, we're going to get into this notion that these repositories are understanding that they're working in enterprise and they need to be able to make configurations available to others to be able to use. Okay. And then we need to be able to get into an enterprise manager that can talk about, for this thread, this is the configuration that we're operating in. And then above and beyond that will be for this enterprise, we're trying to manage all these different configurations, all these things at the same time. They have only slight variations. And as we do change, we want to be able to optimize on where and how we do change and how that's replicated through the system and how that fits into our warranty, our maintenance, our support costs. I mean, there's a tremendous number of interesting dynamics that we can get into here. But we're going to be dealing with some of the legacy along the way to be able to manage for us to get to that point.
You said in passing, as you understand the digital thread or something like that, and it seems to me that the thread is really a sequence of decisions. Sometimes people are thinking a thread is a sequence of revisions to a mechanical part. That's what a lot of people talk about. They're talking about the revision history of a part. And a thread can be different, right? I mean, both of those are actually fine definitions, but I think threads, which get back to your process, I mean, they exist because you're trying to make a decision about something, right? And when your decision goes across multiple products, like a part reuse, you mentioned product lines. I was humored a little bit. You said 20 years. Well, actually, the really good product lines are 50 and 60 years old, where they talked about like a common pump used in multiple products, right? Whether you're talking about washing machines or you're talking about cars, right? There have been common parts, and that's a form of a product line. And then when you streamline the production of your next Camaro, you may be constrained by the product lines of a water pump, right? And I'm choosing a mechanical thing just to point out, while the software guys really need this because the huge options of combinants, right? The different kinds of combinations, it's just amazingly large. Whereas for mechanical parts, it's a few hundred and then you're done, right? So I think this notion about product lines and being able to manage it, the whole managing your requirements in a way that lets you optimize a product line is only understood by a handful of people, yourself included. and the rest of the people are like, well, why isn't it just associated with the BOM? Well, it works fine if you've got 2 products. It doesn't work worth a darn if you got a few hundred products, and it doesn't scale if you got a few thousand. It's impossible to figure it out. That's why you need this other notion, I think.
Well, yes, and you hit on a bunch of interesting things. One being that as we get older in our career, 20 years seems like 20 years when it's actually like 40 or 50 years. So as we use the same phrase back 20 years ago. Well, actually, you're right. It's more like 40 or 50 years, because the whole concept of software product lines comes from exactly what you're talking about, is the reuse that we took place in the initial development of automotive vehicles and then appliances, things like that. But I think that vision in terms of how we look at this data also has kind of a structure to it. And how we look at that end decision, what we want to capture in this digital thread is a larger view. It's not just the end artifact, the end asset. So we might have at the center of this equation, this digital thread, we might have our assets or our requirements, our parts or designs, or those are the things that we decided already. Outside of that, we're going to have kind of our workflow things. These are change requests. These are feature requests. Okay. These are the things that drove us to be able to build that product. And outside of that, even, we're going to have process. Process is going to be what drives us to be able to get to that change flow. And that's really the bigger vision when we get to this digital thread, where the digital twin might be that smaller thing in the middle of what the realization of all of our decisions, and the manufacture of that entity that makes the physical entity. And our digital twin might be the copy of that. But we need to be aware with what were the decisions that we made and what were the rationale of why we would go through and make those decisions. And that's why we have a thread of data. And what makes it so intriguing for us as we go forward here.
Yeah. So I can imagine people are thinking, oh, wow, this might be really complicated. So I'm kind of curious, how do you develop solutions for this? I mean, what's your development approach? There's all kinds of competing things, from something called waterfall to something called agile. Sometimes it's just build it and break it until you get it working, right? I mean, what do you recommend in this complicated space?
Well, I think that we've all done everything in between along the way. I mean, as you're doing different spike explorations of what's possible, the build it and break it and build it again is always a good way to be able to understand some of the new notions. But that's more from the tool vendor perspective. As we're looking at some of these integrations, what's possible, what can happen, what can do that. We don't do that for anything that we release in production, but we do that for some explorations along the way. I think the common answer of most things is we see elements of Agile. That's how we manage our internal tool development. Okay. It's always going to be an Agile process because we want to be able to focus on value. And so unless we get those feedback cycles from our market, from our customers, from the services engagements we have, there's no sense in going off and developing something for 6 months and come back. That being said, is everybody needs to be able to make some decisions. And somebody needs to make sure that they have timelines. Most of the companies that we work with are product companies. And Craig, you and I both come from automotive. The release schedule and the manufacturing schedule is always critical to everythve
Yeah, and, because it's tied to money. Lots of money usually to tool a plant.
Yeah, you can't tell the manufacturing plant, hold on, I'll have a better answer in 2 weeks. Well, that costs a lot of money to be able to do that. So there's always going to be a balance between that, having checkpoints and targets and balance. And that's where I think you see things like SAFe and other development of scaled agile practices are going to be more valuable as the larger you get, the larger you scale. That's usually what we work with in terms of customer bases, are using more large scaled agile approaches. Mm-hmm. internally tend to be a bit smaller of an entity, so we are using just more basics, agile principles internally for our development.
The other thing I've heard with agile is and this surprises the non-software guys a lot, because the thought is, your requirements, it takes you 3 years to build it, you mass produce it, and off you go. The guys pursuing electric vehicles, especially new battery technology, refined electric motors, and then all the power electronics in the middle, they've embraced an agile approach. And it's partly because you said it really well. You got to connect back with the customers, the users, more often, right? You can't wait the 3 years. You got to do it a lot faster. And then you come up with product architectures to let you be flexible, right? To adjust things, maybe even when they're in the field. The cool thing about software, embedded software, is it has almost zero manufacturing cost. It's not like the conventional big factory where I got to invest a lot in ovens and dies and all the rest of that. On the other hand, because it's so bloody easy, it's tempting to release stuff that maybe hasn't been thoroughly vetted, and that you have to guard against, which we've spent decades doing right together. So I guess my point I'm trying to make is I think with Agile, it's great. And you got to figure out the balance of that and the risk you're putting on the end consumer if you tweak stuff. But the requirements aren't crisp. They vary. And even like this recent public policy about electric vehicle incentives, all of a sudden people were saying, well, it's too expensive. And now they're saying, oh, but with all these rebates and stuff, it'll be fine. GM made a big announcement last week about profitable in 2025. And it's really interesting to think through this. Well, as an engineer in the middle, you've got to stay agile, literally the word agile, but also the techniques of agile where you can adjust along the way.
Yeah.
So I wanted to ask you, I'm going to run out of time, which sometimes happens. I wanted to ask you a bit more about machine learning and AI. Does that help any of this? Does it make it easier? Does it make it more confusing? I mean, how does it fit into helping with knowing your configuration as you're making decisions?
So I think that's an interesting question, and kind of to jump back a little bit to what you were talking about before. Is as we look at some of these challenges, whether they're software related or they're chemical related when we're doing with batteries, all these come back down to requirements, and they all come back down to decisions as well. And that's where I think it's so important for us when we look at the data, we look at the decisions that we make, that we understand what caused us to be able to make those. I think your example in terms of, well, if somebody changes the market, somebody changes the economics about electric vehicles, maybe the decision that we made 2 years ago might be different. Or in some of these areas of uncertainty, as we go through and make, we'll call these wicked problems. And wicked problems are ones that you can't fully specify all the requirements up front. And the first step that you make into it helps you make more decisions, but it also sets your trajectory. So you're just narrowing down the field of possible answers. So your first step is important in terms of what direction you go in. But you can't fully answer the prompt until you take that first step. And so what we're talking about is a web of information, a web of data that we're dealing with. And so I think as we better understand the data that we're dealing with, things like AI and machine learning can be aids. They can help us be able to make better decisions, or they can get better at being able to navigate this web of data to be able to say, okay, if the economics change, what are the types of decisions we made that were based on economics that we might want to re-review because it might change what we're being able to do or how we might be able to do it. Maybe there's an incentive that's based on having a range of over 250 miles with an electric vehicle. That's going to get you to a different incentive point. What decision did we make about the weight of the vehicle or the size of the battery or those sorts of things that were made 6 months ago with staff that either might not be there or suffer my problem of recollection of all the different types of decisions that we might make? We don't want to be able to force that on to just simple recall of the engineer, but what are the tools that can assist them and be that navigator through that thread of data? Because as we've changed, we went from having a couple of files on our computer or a couple of models on our computer to just a huge web of information that we could navigate, and we don't want to get lost in.
And I maybe that's the best way to leave it, is hopefully AI can help us know the trail, right? know the way through the swamp of data. And it's not a bad swamp. It's kind of a good swamp because it's bubbling with all kinds of ideas, but it is overwhelming. Our computers, our ability to sense data even, has expanded much quicker than our ability to consume it all, right? And we're going to need new techniques. And I'm intrigued. I keep watching for the people that figure out how to use AI to develop emerging or evolving digital twins, which in our discussion here are what we call configurations, right? So configurations aren't static; they change, right? As consumer
absolutely.
Change. And so, well, Robert, it's been great chatting with you, and there will be many more topics. Maybe we should do this annually, because I think a lot of things are going to happen, especially with the way the electric vehicle evolution, and then also coming out of the pandemic. I mean, there's going to be pent-up creativity that I think we haven't seen in a while. So it'll be fascinating. And I applaud what you guys are doing. Keep doing it. We absolutely need it. I don't think it'll ever be a homogeneous tool set. It's going to be a heterogeneous world. And we can't even predict the kind of decisions we'll make a few months from now. The landscape keeps changing. That's why we need what you guys do. So thanks a lot. Thom, back to you.
Hey, Robert, thank you so much for joining us. And thank you to everybody who tuned in and listened to the Digital Enterprise Society podcast. To learn more of what you heard today, visit digitalenterprisesociety.org. We encourage you to leave comments either on our website, email us, or on Apple or Spotify or wherever you get your podcast joy, so that we know what you enjoy most about this podcast. And then join us every single week for the next discussion about organizational transformation through the use of digital tools and techniques. All right, join us every single week, like I said, for more thoughts, ideas, and actionable information to help you navigate your career. We'll see you on the next episode.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.